Welcome to the first installment of Flipped My Classroom. Today, we are going to be continuing our discussion on the properties of water. This evening's topic is going to be on heat capacity. All right, here we go. Heat capacity is defined as the amount of heat energy required to increase the temperature of a substance. Water, in fact, has a very high heat capacity. What all this means is that as more energy goes into a substance, the temperature will increase. And for water, it takes a lot of energy to change its temperature. Now, why does this happen? This has to do with the hydrogen bonds that occur between the water molecules. We need to add extra energy to break those bonds to allow the molecules to move faster and faster, which raises the temperature of the water. Therefore, any substance that's not polar will not require as much energy and should heat up faster. This plays a big effect on several different things. One is bodies of water in areas like where we live here in Central Florida. Large bodies of water, oceans, lakes, can absorb large amounts of heat and only change a little bit. And once they do heat up, it takes a long time for them to lose heat and for the temperatures to drop. We see this in the wintertime. The water holds the heat better than the land, so that our coastal areas tend to be the warmest, and the middle of the state, like Ocala, tend to be the coldest. In the summertime, just the opposite takes place. The water takes longer to heat up, and the land heats up quicker, so the coastal areas are cooler, and the middle of the state is actually the hottest. And you can see this in this little diagram here from Channel 2. This is also noticed at a cellular level. Water absorbs heat produced by all of our cellular processes. It regulates the temperatures of the cell, and also, since the blood is mainly made up of water, the blood heats up and can transport heat away from certain body parts. And we can actually cool the body by cooling our blood, and it carries the blood, and then the blood travels throughout the body. Now, tomorrow's lab, it's very important that everybody reads over the procedures in class, or for class, before you come into class. I've shared a document on Google Docs with you. It's titled Heat Capacity Lab. When you look at it tonight, make sure you also click on the spreadsheet link towards the bottom so you know how to enter the data. I'm going to show you real quick. First of all, let's look at the lab itself. You notice up here, Heat Capacity Lab, we have a question: how does the heat capacity of water compare to other materials? Which materials will have the highest heat capacity? You've got to create your own hypothesis. The results of this experiment will show, and you can do that in class. You'll need to know your variables, what constants. I have a list of materials that will already be at your lab station and a series of procedures. You'll be working with 2 flasks. You need to fill both to the 75 milliliter line, one with room temperature water, one with the substance that's supplied at your lab station. You'll be placing stoppers over each flask, and there'll be a temperature probe in each stopper. Make sure the probe is in the material but not touching the flask. Make sure the probes are working. You can do that by looking at the Vernier LabQuest to see that it's registering temperatures. You also have a glass Pyrex Pan. It needs to be filled approximately 3/4 full of either hot or cold water, depending on what lab station you're at. And you can tell from the spreadsheet what you will need. And if you place the flask in the water, you should fill the water up in the pan so it's also even with the 75 milliliter line. You'll be recording temperatures of the water in the pan, the water in the flask, and the substance in the flask every minute for 12 minutes. And then there are some questions here to answer towards the end. Let me show you the data table. This is the spreadsheet I told you about. I have it divided by each station. Here's lab station 1. They'll record the temperature of the water, the temperature of the material, and they'll do that for 12 minutes. And as they do that, the graph over here should create itself. Each lab station has their own data table and graph. And that should be everything we need to go over. See you tomorrow in class.